Can you hear me now?
Yes.
Turning on the microphone really helps.
Yes.
All right. So that explains why Taylor didn't respond to me when I was saying, hey, let everyone know I got to walk the dogs. All right. So before I go over the slides for tonight, any questions on this week's work, last week's work? Any question on the project? Any questions on anything database related, non-database related? Start with an open forum.
Can you hear me, by the way?
I can hear you.
Oh, perfect. So my other class, I'm learning about Postgres SQL.
Yeah.
Is that pretty much just like similar to SQL? Like it doesn't look, I'm sorry, it looks similar. Like I don't see anything that's off so far.
So you know how like Spanish has like 5 different dialects and like there's just little differences between each of them?
Yeah.
Same thing with T-SQL.
Okay.
Postgres has a couple of things. See, you've got T-SQL is the language that everyone uses, and then like, you know, Postgres, MySQL, Oracle, NoSQL, Microsoft SQL Server, all just minor differences in how the language works.
Okay.
So it's good if you get the idea of, if you pick one of them and get really good at it, when you look at the others, you'll kind of get the idea of what's going on. Like for example, you know, like we've got the auto increment for tables in MySQL to make things up. In Oracle, it's referred to as a sequence, and it's a separate object that you create. And in Microsoft SQL Server, it's called an identity clause. And they all three do the same thing. They're just different ways of getting about it. And you can't do identity in any of the other two, or nor you can do a sequence in anything else. So just different ways to get the same thing.
Okay. Thank you.
Yeah. What class is it in Postgres?
CS. I can't remember. 341. It's
Okay.
web backend development too.
Yep. I'm surprised. A lot of web backend stuff you're going to find runs on MySQL because it's free. And it's a standard install for like your web services and stuff. But Postgres is not free, but it's a pretty powerful tool. I think
We're using it through Heroku right now, and so it's free through there, I guess.
Yeah. Educationally, if you want to use it for development on your own, like you're doing something at home, that's fine. But if you try to do anything live that you're making money off of, it's
gonna charge me.
Yeah.
Okay.
Yeah. Microsoft SQL Server and MySQL both have free offerings. Even like in AWS, you can go and build databases for free out there. They're not really big, you know, they're tiny things, maybe like 100 gigabytes or something, but you can build databases out there. Oracle is never free. Oracle is, of the 4 of them, there's way more than that. Oracle is by far the most expensive of them. Oracle is like going to like a really fancy restaurant where you get your main course, but if you want side dishes, they cost extra. You know, like I wanted a steak, but I want a baked potato, but the baked potato is $6. I wanted a plate was $7. So that's Oracle. I think where I work, our yearly bill for Oracle services is something in like $12-14 million, and Microsoft SQL Server is like, you know, 750,000, maybe $1 million. Well, Oracle bills itself as a Oracle has. It's not like it's not worth the money. It's definitely worth the money because of what you get out of it. But Oracle has built itself as being like this giant database server for like massive financial applications. In fact, application called CostPoint, something called PeopleSoft, Deltek T&E. Those are 3 major things that work on Oracle that they're like giant, need giant processing power. And Oracle is really good at that. I mean, Microsoft's not bad at it, but you can run that stuff on like Postgres or MySQL. So, you know, you pay for it, yeah, but it's worth it. Any other questions about this week's work? Let me ask you a question. Has everyone successfully navigated the proctoring thing?
I downloaded it, but I haven't like taken the quiz or anything.
Okay. Let me know when you take it, because I've had a couple of students with problems with it, so I'm trying to find out if it's you know, where the problem's lying. help has been hard to find the last couple of days because I don't know if y'all noticed, but iLearn and Canvas and all the good stuff was out for 2 days.
I noticed.
We noticed.
Yeah, everyone noticed. Like,
I've
I'm
noticed
trying,
about it.
huh?
I've noticed about it.
Yeah. It was funny. They sent an email, but I didn't get the email because the email wasn't working. So that wasn't the most efficient way of letting us know there was an outage. But, you know, things happen.
I had a question.
Sure.
I'm trying to set up my ERD for the project,
Mhm.
and there's a couple of things that I have a question on. Would we have time to look at that tonight?
Yeah, let's go ahead and do it right now.
Okay.
Let me make sure you can share your screen because I keep forgetting to do that. Share screen. Is it checked off? Okay.
Okay. Can you see the Excel?
Yep.
Okay, so I'm assuming it's just any app that we can do.
Sure. Anything you want. Real, fake, whatever.
Okay, so I'm just chose like a app that I shop on.
Okay.
And the problem that I'm having is I don't know, like there's different kinds of products, like for your face, for your
Mhm.
eyes, your lips, your skincare. I don't know if I should have a different table for every single one of those, or if it's gonna duplicate, or if I should just have them be separate like this one.
So, okay. This is a really good question. So let's dig into this a little bit. So you want to do obviously for makeup, some kind of like an Ulta type store.
Yeah.
Okay. So let's look at this. So you have a product table. Okay. So you got a name of the product. That's good. You got brand, type, price, color, quantity, SPF, form, finish, and coverage. So I haven't done makeup. Fair warning if I haven't mentioned my degrees in theater, so I understand makeup fairly well. Looking at that, brand, well, the first question is, would a product be used on multiple body parts?
I mean, it can be, but generally not.
Right. So I mean, you can use foundation on your legs if you wanted to, but mostly it's done on your face. So what
Right.
I would say, you have a one-to-many from product types to product. So I don't think you'd have like, and even if you did, you could like, you do like 5, like 4 would be skincare, 5 would be like everything, like all purpose, you know? So that would work. Type that. So brand would be, you'd probably make a brand table and do a one-to-many because one product name only comes from one brand.
Can do that one to many.
Yep. So like your brand ID would go directly into the products table. So you'd have the one-to-many there. So you have brand ID, brand name, you know, anything else, you know, stuff like that.
Okay.
I don't know that SPF would be there because I don't think everything would have an SPF, or does everything have an SPF at this point? Like does
No, that's what I was confused about because it's either on the app, it's either it doesn't have it, it's between 15 to 30 SPF or higher than 30. So I don't know if that'd just be like enum or something, or I don't know how to put that in there.
Okay, so if that was the case, you'd probably do a table for SPF and do like, you know, ID 1, none, ID 2, 15 to 30, ID 3, 30 to 35, ID 4, you know, sun.
Okay.
So maybe something like that, because then you have a one-to-many there.
Okay.
Form? What is form? Oh, okay. Liquid, stain, cream, grass.
So I left that over here because I didn't know if it even needed its own table.
So here's the trick about this. So when you're developing a database, you got to think how the front end is going to work. And forgive me for saying this, you've got to realize that your end user is not going to be the brightest bulb on the Christmas tree. Okay. So whenever you're designing a table, you want to make sure that the front end application puts the data into the database with as little chance for mistakes as possible. And the best way to do that is to make sure there are drop-down menus to populate the things in the database. Okay, so your database will populate the drop-down menus, which will in turn populate your database. So things like form. We have, you know, Sally in receiving who has to type all this stuff in, right? And, you know, one day she fat fingers and spells liquid wrong, and all of a sudden an entire line of liquid bases, foundations are misspelled. So we want to make this as simple as possible. So an extra table is not necessarily just to normalize and to do so that it's sometimes for the benefit of the application. So in this case, if form, and I'm not sure if form would be the best word for it, probably, I can't think what would be better. I'll have to think about that for a second, but there's like a word like on the tip of my tongue that I can't grab right now. So that would be, that would also populate the drop-down list for someone searching for something. You know, I want to find all eyeshadows, everything for eyeshadow that is also stained and stuff like that, you know? So we want to give people choices. So you'd probably still keep it that way and use form ID over there, finish ID over there. Same thing, matte, illuminating. So that would work too. But you'd probably have to make sure to have one that's like for finish, like not applicable.
Oh,
know?
okay. Yeah.
Because like, you know, not everything's gonna necessarily have a finish. So yeah, I think this is going to, that's good. Yeah, so you got the form table. Now coverage, full, medium, buildable, light. Yeah. Yeah, I think you've got a good concerns, face makeup. Now we're getting, with the face makeup table, that's going to be a little, everything that you're starting duplicating stuff because all that stuff is sitting in product.
Yeah.
So, you know, you wouldn't need that because you have type face. So you wouldn't need the face makeup table because everything's there already.
Okay. Cool.
Yeah. So I think if you get rid of face makeup, you got a pretty good start here.
Okay.
You might want to start building like, you know, like a customer table and an orders table and kind of figure that out too. But you're at 1, 2, it's supposed to be 12 tables, right?
Yeah, I started doing this one over here, but I wasn't sure how to set it up yet, but with the customer information and the shopping cart.
Right. Well, don't worry about the shopping cart. Shopping cart is an application thing and not your
Okay.
problem.
Okay.
So you just need to make sure that the information would go in there. So if you look at the database that we're playing on, the Sequila database, it's got a fundamental, a rudimentary way of doing it. So you can copy that. But another thing, whenever you're doing stuff like this, if you go out there and like, you know, Google customer service ERD, you'll get a bunch of them. You can get some ideas off of how to do it from there. And there's absolutely nothing wrong with doing that.
Cool.
But yeah, this is a good foundation.
Oh, good. So the way I set this up first, I did concerns like this, like that, but I'm pretty sure, should I switch this one to look like the concerns one?
So preferences, what do you mean preferences? Whose preferences would these be?
It's like the customer's preference. So
Okay.
if they want it with like vegan, or if you have oily skin, you want something with oil free, I mean.
So what you'd need to do is this wouldn't necessarily be your preferences table. So what you'd want is a table, so you want a table that would have these things in it. So you call it like, you can call it the preferences table, sure, but it'd be like ID, and then like clean ingredients, cruelty free would be rows, not columns.
Okay.
Okay, because then you could set it up to where you'd have preferences in your products table. So you wouldn't have a preference ID here, because here we're looking at a situation where we're looking at many to many, right?
Mm-hmm.
So one product might have many of these preferences, and one of these preferences have many of these products. So you'd need to do a product preference table, right? So here you'll have ID1, clean ingredients, ID2, cruelty-free, ID3, vegan, ID4, paraben-free, so on and forth, right? And then you'd have a product preferences table where you'd have the ID of products and the ID of preferences in there, right? And
Mhm.
then you'd say, okay, product ID1 is clean, cruelty-free, vegan, and oil-free. So you'd put the 1, 2, 3, 6, 7, 9, whatever it is, right? You'd also link this up to customer preferences, where you'd have a customer table, right? And then you'd have a table called customer preferences, and any of these things that the customer prefers to see, you link it there. Is that making sense?
Yeah, it does.
Yeah. So that's what you do, because that way, like when a customer logs in, you can have like, if let's go big picture and see a forest here inside of Freeze. So if you have the customer preferences in the database, right? When they log in, you can have a procedure that says, show the customer everything we have on sale based on their preferences on their launch screen. You know, because like if you think about it, like all the social medias, like Facebook, all them, they keep track of the cookies. So when you log in to Facebook, they look all those cookies you have. So I don't know if you know this or not. If you don't know this, you might be terrified. So all the cookies you have, Facebook is constantly reading those and putting them into their database. Even when Facebook isn't on your computer, it's constantly reading on your device, wherever it is, it's constantly reading everything you search is being put into their database. So that's why when you log into Facebook or Instagram or any of that stuff, when you log in, the first thing you see within the first 3 stories in your feed is the last thing you looked at on the internet search.
Yeah.
Because they're using that data against you or for you, depending on how violated you feel by it. If y'all haven't
They show
watched,
me anything good.
well, that's true. You know, I tested it out. I searched for something completely ridiculous, like Norwegian rats, and like I got like trip to Norway. I'm like, oh. But if you guys have not watched on Netflix, there's a show called The Social Dilemma. Ignore the parts where it's the family dealing with this kids who are addicted to the internet. But if you just watch the developers of Twitter and Facebook and Instagram tell you what they did to that application, it's pretty terrifying how they deliberately did things.
That's interesting.
It is very interesting. Yeah, I could talk about this for several hours, but so no, this is a very good start. I like this. Concerns would be a table that you'd have customer preferences, and you'd have customer concerns as a separate table.
Okay.
Okay. You might find a way to link the concerns table to the products table, like you know, this is anti-aging, this is for dryness, this is for redness. So you might have product concerns and customer concerns.
Okay.
So if, you know, again, so when the customer logs in, oh, they don't like the redness. Here's some new show the user all the new products for redness when they
Okay.
log in. You know, but this is an excellent start.
Cool. Thank you so much.
No problem. And like I say, if you can, every week we can talk about it and go over it, and that's fine. If you want to do some one-on-one time, we can also do that too. But this is good so everyone can kind of see how projects are going on. Because I do think it's the better option than the final exam.
I agree.
Anyone else got any other questions? Or I'll just jump into the slides tonight, and then we can talk about some other stuff. All right, let's just jump into the slides. This is, I love talking about joins. So let's see how off the rails I go tonight. There's my slides here. Okay. Let me share out my screen. And I'm just going to share everything out because that makes it easier. Okay. So here is this. Maybe it's over here. Okay, we're talking about, this is great. We're talking about, okay. Querying multiple tables. The whole purpose of databases, so these are called RMDB, relational model databases. So like I said early on, an Excel spreadsheet is a database because it holds data, but it doesn't relate to anything else. You can now, because of macros and everything else, you can have one sheet talk to another sheet, but it's very bulky. It's very hard to do. If you don't know the equation right, it'll get all messed up. So a relational database, relational model database is one that has multiple tables that can be queried together to provide one pane of glass view for your data. Move you guys a little further here. Okay. You've got cross joins, you've got inner joins, you've got outer joins, and self joins. We're going to talk about outer joins, we're going to talk about them anyway. So cross joins get you a Cartesian product. There's a cross join and an inner join are essentially the same join. The products just like, we'll look at a little difference. We'll look at the second the difference way the results work, but you almost always use inner joins over cross joins. An inner join is joining two columns. Do you guys remember back in the, where is it? I know I've got it here somewhere. Hang on. New share, whiteboard. Okay. You all see my whiteboard?
Yes.
Okay, good. Okay. Where's my shapes? Shape, text, select, so draw. Okay. Draw, give me a circle. Do y'all remember back in elementary school when they talked about sets? Or the Venn diagrams. Does anyone remember the concept of Venn diagrams?
Yeah.
Okay. So
Yeah.
so all joins are Venn diagrams. Okay. So this table is, we're going to call this products. We're going to riff off of Christian stuff. Products. And this one is, we're going to call this one types. Okay. So the purple circle are all the products. The green circle is all the types. This area here, if I can get something to color in with, would be great. Draw, give me, erase, format, undo. I don't know. Do I have a drawing tool here somewhere? Huh, you'd think I would. This area here, Sauron's eye. All right. Oh, that almost works. Okay, this red area here is where those tables intersect. Okay, so anything that's here exists in this table and this table. So if we had we had a bunch of products. We're gonna go over here. We're gonna go doing this stuff on the fly, but at 7 o'clock at night just lacks creativity. Let's see. We got we're gonna do this differently because it's gonna be something that I can do off on the fly really quick. We're gonna do superheroes. And we're gonna do publishers. Okay, so if we have one, here's Superman. One over here, one. Let's move this over here a little bit so we're not gonna run into things. 2 Spider-Man, 3 Invincible, 4 Bloodsport, 5 Prime. Okay, and over here we have 1 Image, 2 DC, 3 Marvel, 4 Unity, Unity, and 5 Goldstone. Goldstone. Okay, so here, we have these guys over here, and then we have these guys over here. Okay, so now Superman is DC, so he goes here. DC's here. Spider-Man is Marvel. He's in the middle. Marvel's in the middle too here. Prime comes from a thing called Gold Coast Comics. That's not here. So Prime stays over here. Goldstone Comics is Disney's old label. There's no Disney thing here, so that stays over here. So Superman, Spider-Man, and Invincible is Image, and Bloodsport is Unity. So these 4 guys are in this part. These 4 guys are in this part, and these 2 guys sit out there. Okay. So whenever we do an inner join, this is the area that an inner join deals with. Okay, and only this area. Now, you don't have to have the inner join area delineated by foreign keys, but it is much better if you do. Again, foreign keys are the conditions or the constraints set on a database where the column in the main table that is reflected in the secondary table, okay? The values in the secondary table have to match what's in the main table, okay? So you cannot put, if these are all here and the superhero table, you try to put publisher value number 6, it's not gonna work because there is no 6. This is another reason why your tables power your drop-down menus for your website, so no one puts things in that aren't supposed to be there, okay? So your inner join takes this area here. I don't know if this is talked about here, but let's talk about this. So there's 2 other joins. There's left outer and right outer. Okay, so these are the 2 other joins that I'm going to talk about right now. I'm not sure where they land in the lesson, but I'm going to talk about them now because I got my Venn diagram up and this is what we do. Okay, if I'm talking about a left outer join, so real simple, let me go here and do superheroes left outer join publishers. And then let me go over here and do the same thing except do right. Okay, so when you do a left outer join, so when you do an inner join, it only returns what's in here. So you'll never see 5 or 5 show up in your result sets, okay? If I were to do a left outer join, like this one here, superheroes left outer join publishers, what this query does, it returns, and let me change the color of this to purple. A left outer join returns every screen. I didn't want that. I wanted purple. Purple? Nope, still red. So I'm gonna do hearts then. A left outer join, a little heart here, returns everything in the left table, but only the things that match from the right table. So that means if I return this, I'd get Superman, Spider-Man, Invincible, Bloodsport, and Prime would show up. Superman would do DC, Marvel, blah, blah, but Prime would show up as a null. So the publisher column on the result would be null because there's nothing there. Okay? Left outer join returns all from the left table. And the left table is the first one in the join. So table, inner join, left table, join table. Okay? The first one is left, the second one is right. In a right outer join, it's the opposite. Okay, everything in the right table is returned, but only the things that match in the left table, from the left table. So image returns, image would return with Invincible, DC would return with Superman, Marvel with Spider-Man, Unity with Bloodsport. Goldstone would be returned, but there'd be nothing next to it, be a null. Okay? So really, these are the three types of joins you deal with on a regular basis. The last one, which I forgot about, there is a final one, is the full outer join. And the full outer join does exactly what you think it does. It returns everything. It'll return all the heroes and all the publishers, and will return the ones that don't exist in the other one with nulls. So Spider-Man and Superman and all these would return, but both of these would, Prime and Goldstone would also be returned, but they would have nulls in their companion values from the other table. Is this making sense?
Wait, sorry, could you say the last thing again? So you said a full outer join?
Full outer join would return everything in the left table and everything in the right table. So the result set would look like this. So if I was just returning IDs, right? So a left outer join would look like this. Would be 1, 2, 2, 3, 3, 1, 4, 4, 5, null. Okay, does that make sense?
Yes.
Okay, a right outer join would return like this. Outer, okay. It would return, okay, so we're gonna do the publisher ID first. So do 1, 3, 2, 1, 3, 2, 4, 4, 5, null. Okay, does that make sense?
Yep.
Full outer join would look like this. And I'll be a little more specific here because I'll do hero ID. Because it'll get confusing if I don't do this. And then publisher ID. So 1, 2, 2, 3, oops. 3, 1, 4, oops, 4, 4, 5, null, null, 5. Do you see?
Yeah, okay, I'm seeing the difference.
Yeah. So everything will get returned. So here, because this is left outer join, this only got this outer return because this is here and not here. So there is no matching here, right? In right outer join, because this is publisher ID and this is hero ID, this got returned with a null because there's nothing here. But in a full outer join, it's going to return everything. And it's going to return this because this exists in both, this exists in both, blah, blah, blah. This exists in the one but not the other, but it's going to return because it's full. And this exists in one and not the other, but it's going to return because it's full. So it's returning everything, regardless if it has a match or not.
Actually, that's the on clause that matches the table.
I'm sorry, what?
The on clause on that matches the table. The table.
The unclass that matches the table?
The on clause.
Oh, the on
Yes.
clause. Oh, yeah, the on clause. Yeah. So yeah. So, oh, that's right. So here the on clause would be so we're going to assume that the heroes table is hero ID, publisher ID, and publisher ID. Publisher is actually, in all honesty, it would look more like this. Hang on, let me okay, so I really should draw out these tables. Let me clear this up. Okay, let's do this. Let's clear all drawings. Okay. So let's do, okay. Okay. So let's do this for real, and let's see where this takes us. Because here's how you'd really set it up. Okay, so over here we've got our heroes. Okay, we have hero ID. And we'd have name. And a bunch of other stuff, but we're only going to go with the 2 columns. And over here, we would have publisher and pub ID and let me get rid of this because we're not going to get technical, and publisher name. Okay. So now, here we have a, okay, let me do here, and then over here, forget that. And do pub ID. And over here, we'd have, we wouldn't put the hero over here, so it's this. So over here, we would have an arrow. We have a foreign key constraint here. Okay, so we got a foreign key saying the publisher ID must be here. To be here, it has to be here. So that's what our table structure would look like, right? So if we were to write a query on this, okay. So this would be the first iteration of that query. This would return, and let's real quickly. Let's put you guys over here. Let's give me my select here. Give me my select tool. Give me this. Let's move this a little closer. Oh, no, it's not gonna take everything with it. Okay, that's fine. Okay, so again, we have 1 Superman, 2 Spider-Man, and then 3 we'll do Prime.
Remember, the ID can be used as a same table. Is that right?
I'm not sure what you're asking. We have a one-to-many relationship because one hero can only be in one publisher. So we don't need a join. We don't need a join table here. We don't need a bridging table here. So over here, we got one Goldstone, 2 DC, 3 Marble. Okay. So the result of this query would be 1, 2, 2, 3. Okay, does that make sense?
Yeah.
Okay. So now the next query, I'm going to do a right, let's do a left. Okay. So the result of this query would be 1, 2, 2, 3, 3 null. Okay. Move this off to the side so we can keep the okay. Put this over here, right there, and the result set would be that. So the next one, there, no, back over there, come here. This result set would be text over here. Would be 1, 2, 2, 3, null, 1. Okay. You still with me? That makes sense?
Yep.
Okay. And then the last one, this result set would be 1, 2, 2, 3, 3 null, null, 1. That would be the on clause, because the on clause would be the one that appears in both columns. All right. All right. So,
Yeah.
okay. Moving on back to the slides. Okay. Oops. Oh, I didn't mean to do that. Screen share. Share the screen. Okay. The other thing you do sometimes you have to do is self join. We'll get there in a second about self join. Self joins can be unnecessarily complicated. Okay. So retrieving information from 2 tables is considered a join using a foreign key. Okay, you don't have to use a foreign key to act as the transport between the two. It doesn't have to be a foreign key. It should be a foreign key, but it doesn't have to be a foreign key. For example, let's take a look here real quick. Let's see something here. Let me fire this up. Okay. Okay. I just want to look over here. We have actor last name, and then we got customer, and we got customer last name, okay? So in the ERD for this, the actor table and the customer table is not linked in any way, shape, or form. So let's look at the film. So here we have the film table and the film actor table, right? So the actor ID is linked in the film table. Okay, the film ID is linked here, and the actor ID is linked here, right? Those are all foreign keyed. If I did a query by them, like, you know, select actor last name, comma, F dot title from actor as A, inner join film as F. Nope, has you film actor. A, FA, on.
Don't forget on. Don't forget the on clause.
Oh, I'm doing it right now. On film actor FA. Sorry, no, I was about to do it there. Okay, hang on a second. Doing the on clause right now. On FA dot actor ID equals A dot actor ID. Inner join film. Actually, let me do it here. There we are. It'll like that better. Film F. Good grief. On. By the way, I'm a horrible typist. There's a standard rule to never do live typing in demos, and I always break that rule. So I apologize for the bad typing. Film ID equals FA dot film ID. Okay. So I did not new database. Oh, that's because I forgot to use Sakilla. Okay. Now, okay. So we got our names and stuff like this. Okay, so now, and I showed you because it's foreign keyed, but I could do this even though there's no foreign key. Select A dot last name, comma, C dot last name. I'll do this by hang on a second. I don't know if any results are going to come back, but I'm going to do this. Just change this. Oh, that's not going to work. Hang on, I lied. SC. Oh, I'm doing something a little different. Inner join actor. A. Okay, so I'm joining the actors table and the customer table on the last name column. There is no foreign key between them, but it's still going to return values. The foreign key is there only because indexes make it easier to search, and something that is foreign keyed is indexed, right? We don't have indexes on last names, and we have no foreign key there, but results still come back. So does that make sense about foreign keys don't have to be there?
Can you repeat that one more time? I don't understand.
Sure. So the slide said that foreign keys have to be present for joins, and they don't. Back to the slide here. Retrieving information from two tables requires a query that instructs the server to use the foreign key to act as a transport between the two tables. This is true, that when there is a foreign key, it does act as a transfer between the two tables. However, a foreign key is not required to make a join happen.
Okay, thank you.
Okay, so like I said, in this case, there is no foreign key between the last name column between actor and customer, but we still get information back. And if I went here and I did, let's do some left outer joins. So this is my results for, actually let me do it this way. I think this will return a different column that's what I want, so let's see. So all I want to do at this point, I just want to do last names at this point now. So you can kind of see, okay. Okay, so when we do it this way, we get 43 rows returned. If I do with a left outer join, oh, oops. If I do it with a left outer join, see I start getting these nulls here? So I'm returning everything that's in the customer table, but that isn't in the actor table. So I have no nulls in this column at all because this is the customer table. If I do the reverse, I do a right outer join, and I got 620 returned. If I do this one with the right outer join, this is my right table because it's my actor table. This is my right table, and then this is the customer table. So everything's been returned here, and only where it matches here. Is this making it clearer?
Yeah.
And then here's my full join. So the first one that was the right outer join returned 620 rows. The one that was left outer join was 620 rows. The right outer join was 200 rows, and the full join why is my full join not working? All right. This is one of those things I talked about syntax before. Okay, I'll look at the anyway. The full outer join would return everything nulls on both sides. So, all right. So at least for right now, do right and left joins make more sense? You see where that's coming from? And that's my whole point of this whole thing was you don't need the foreign key there. All right. Cartesian product. If we do not specify in the query how to join the tables, the server will generate every permutation between the two tables. That is, the server will join every item in the one table with every item in the other table. Suppose there are 30 items in table 1 and 43 items in table 2. Without defining how to get the joins, the server will generate 1,290 results. That's the Cartesian project, okay? That's why we don't do that. So what that looks like, I'm not gonna run it, what that looks like is this. How does it run it? And we get 1,000 rows returned. Okay. It's not, look how nothing's matched up, right? Ackroyd, Abney, Ackroyd, there are 3 of these, and so all these Abneys here, and then we got, you know, Adam. So it's matching up everything in the customer table to everything in the actor table and returning 1,000 rows. So this is why we don't use those. Okay. And we just did something like this. Select first name, last name, address from customer, join. So if you just do join, it's by default an inner join. You don't have to put the word inner there. Join address A on address ID equals address ID. So this is the column where it'll be joined on. Because it's an inner join, it has to have something exist in both of them. Okay. Got the inner join. This is inner join between 2 tables, which what I just showed you. Multiple table joins. You can join as many tables as you want. It just gets more and more confusing. Imagine the Venn diagram with 10 circles. Okay, it can get a little confusing. So in this case, we're selecting for the customer table, joining to the address table, joining to the city table. The reason we would want to do this is because in this particular database, if you've noticed here, our customer table doesn't have their address in it. It has an address ID. So we've got an address table where their addresses are. Okay. So if we want to know all the customers from a particular city, we can't query the customer table. We've got a customer table and the address table, like they're doing in this slide here. So here, and they've gone one step further, is there's a city table. So we got a city ID here that connects to a city table. To me personally, this is, and we got a country ID. This to me is over normalized, but you know, it proves a point here. Okay. So if I want to know what city someone's in, I've got to query address, city, and customer, like they have in the slide here. You can also, you don't have to use a table. You can join to a query. Okay. And that query can have a join in it. So if you're to run this query, it pulls all the addresses that are in California without listing all the addresses. So just first name, last name, city, and you can just do this. Okay. Using the same table twice. So we're this query here. Let me copy this and clean it up and put it into the query window so you can watch, so we can go over a little bit more in depth because, like I said, self tables is a little tricky. So give me 1 second here. Okay. Okay. Select F title from film and join. Why are you not working? Film and join on film. So we're selecting from film, interjoining to film actor as FA1 on film ID equals FA1 film ID. Interjoining on actor one, an actor with A1, that FA1 actor ID equals FA1 actor ID. Then interjoining on film actor as FA2 and interjoining as actor 2. And it's all because we want to do this here at the bottom. So we want to show all the films that star Kate McQueen and Cuba Birch. There are other ways to do this, but the point is we've instantiated actor twice and we've instantiated film actor twice. Also that we can do this. A good exercise is to look at a query like this and see how many different ways you can rewrite it without having to go through all this. Okay. I don't know why this is showing up as something.
The where clause, of course. Don't forget the close parentheses.
Ah, good catch. I must have deleted by accident. There it is. All right. There we go. It's just those two that come up. You're good at troubleshooting code, Teo. My personal kryptonite is parentheses, because sometimes you'll have like 30 of them in one query, and trying to find where the one missing is a nightmare. Okay.
You're welcome.
So we've got. So that's why we instantiate a table twice. Okay. All right. Self joins. We're joining film to itself. Select title and title prequel, because in the film table we have whether it's a prequel or not. So this will return everything that's a prequel to itself. Okay, you can run this one on your own. So yeah, I guess next week we'll go into outer joins. But yeah, so that's pretty much how the inner joins work and some of the outer joins. I'm gonna be, when I post this video, I'm gonna add another video. I did a video 2 or 3 years ago that's just all about joins. It is using Oracle, not MindSQL, but the concepts are the same. So I'll share that out when I share this video out. Okay. Get a little drink. Anyone have any questions on cross joins or inner joins?
No.
Okay.
Yeah, none here.
Okay, Christian.
I'm good.
All right. Okay, well then, if you have any problems, we'll go ahead and have you all noticed that the answers to the exercises are in the back of the book?
Yes.
Okay.
Yes.
Yes.
So as a forewarning, we've added questions to the exercises that are not in the back of the book. So let's see if they've added them in here. Quizzes. Quiz number, no, exercise, yeah. Let's just preview it. One question. Oh, they added them in. Oh, they have not added them. So they may not have added them today yet, but they may or may not add them between now and then. Has anyone done the exercises yet?
In progress.
Okay. So if you do them and they add the 2 extras, it's not going to count against you. But just be prepared that we're going to be adding questions that aren't in the back of the book. Sorry.
So just to clarify, it's going to be the exercises in the back of the book plus some other ones.
Yes.
Okay.
Basically what it'll be is we're going to round everything out to 5 questions, 5 exercises. So if there are 4 in the back of the book, there will be 1 that's not, or if there's 3 in the back of the book, there'll be 2 that aren't. But they're all in the same vein of what's there. Is we just want to be able to challenge you guys a little bit. The original discussion was like, will they realize the answer in the back of the book? The answer was yes, they're going to realize the answer in the back of the book. But we want to give you guys a little bit of extra, just make sure you get this, particularly now with the project being the thing. Make sure that you guys really are aces on your query rating.
If we get them wrong, will you give us the answer to show us what we did wrong?
Absolutely. That's what, and yeah, and believe it or not, there are some people who are getting wrong exercises now. So there are people who are working on them, which is great. So yeah, I will say I will either ambiguously give you the answer and give you an opportunity to fix it and get the points, or I'll just tell you straight up what it was. Usually if it's a difference of like 1 point or 1.5 points, I won't give you the chance to fix it is not going to make a huge difference. But like out of 5 points, if you got got 1 out of 5 points, I'll give you the chance to fix it. And that's you just email me the answer and I'll change the grade rather than go back in there and fix the quiz.
Cool.
Yeah. All right. So that's all good. If there are no other questions, I will call it for tonight and let this thing render so I can post it with my my joins video. Again, I like doing a lot of things on the fly because it's more interesting that way. If we kind of like trouble this out, and it shows like you know I've been doing this 20 years and I still miss parentheses in code. So when you guys miss parentheses, just remember Brother Stevic is doing this forever and he's missing parentheses, and and actually just call Teo because he'll find it for you because Teo's like crack. He's got the gold star for today for code troubleshooting. All right. If there are no other questions, you guys have a great rest of your night.
Thank you.
Thank you.
Thank
Bye,
you.
guys. Bye.